G'day, welcome to another Saturday Science Summary. I'm Ray Tomes from New Zealand, and today I'm going to talk to you about a cycle of around 27 million years reported in a variety of different phenomena, from mass extinctions to geological activity. Recently, some articles appeared saying the Earth has a pulse 27.5 million year cycle of geological activity discovered. Or in another source, a pulse of the Earth, a 27.5 million year underlying cycle in coordinated geological events over the last 260 million years. So what we've got is, at these particular points in time, a lot more things happen, and there's big changes, and they are when the names are given to the different ages in geological deposits, these the periods tend to have lengths that are either 1, 2, or 3 times this 26, what I call 26.65 million year interval cycle in these things. The same thing has been found in mass extinctions. So let's look at the present articles to see what they've come up with. First of all, here's a picture that came with this one article showing the zones between the plates and plate tectonics and all the other places where the activity is happening. This is showing in the modern time what's going on, and it's a pretty picture showing how these things are happening. But we're only experiencing this in human time scale. We're talking now about vastly longer periods. Does rather more happen at those times. So the source of these articles in the popular press is from a magazine called Geoscience Frontiers, or a journal I should say. And it's titled, "A Pulse of the Earth, a 27.5 million year underlying cycle in coordinated geological events over the last 260 million years," by Michael Rampino, Ken Caldera, and Zuhong Zhu. Sorry for my Chinese pronunciation. Let me read you a bit from the abstract. "We performed spectral analysis on the ages of 89 well-dated major geological events in the last 260 million years from the recent geological literature. These events include times of marine and non-marine extinctions, major ocean and anoxic events, continental flood basalt eruptions, sea level fluctuations, global pulses of interplate magmatism, and times of changes in seafloor spreading rates and plate reorganizations. The aggregate of all 89 events shows 10 clusters in the last 260 million years, spaced at an average interval of 26.9 million years, and further analysis of the data yields a spectral peak at 27.5 million years at the 96% confidence level. A short series of 8.9 million years may also be significant in modulating the timing of geologic events. One result suggests that global geologic events are generally correlated and seem to come in pulses with an underlying 27 million year cycle. These cyclic pulses of tectonic and climate changes may be a result of geophysical processes related to dynamics of the plate tectonics and mantle plumes, or might alternatively be paced by astronomical cycles associated with the Earth's motion in the solar system and the galaxy. Okay, so let's say these two periods, they get a 26.9 by one measure, 27.5 by another. I'm going to state that this period is 26.65 million years, and it's related to other things that are going on in the universe. They give an 8.9 million year period also. Now this shows up in other things, and I have reported this, for example, in the magnetic reversals of the Earth. I found a 1.11 million year period and a period of close to 9 million years, which I believe will be 8 times the other one, so it'll be 8.88 million years. So these figures should be in our mind. and I'll show you a table that I've produced that mentions these later on and shows the relationship between them all. This spectrum shows all the events that they found, and it gives you two periods, 27.5 million year and 8.9 million years. Spectrum is done running from left to right here. We see the frequency, and up the vertical axis we show how strong that frequency is present in the data. The peaks are labelled with the period. Period is just the inverse of frequency. So we're seeing those two periods there. We see there are some other peaks not so big. Those ones that they've given there are the significant ones. This is a spectrum that they found of non-extinction events. So the other one has been dealt with before with the extinction events and been shown to have this about 27 million year cycle. It's been variously reported as 26 or 27 million years. And this one shows, it still shows that period, but it shows another one at 39.3 million years. And as well as the 8.9, a couple of others at 9.8 and 6.4 million years. So the interaction of all these different periods coming along, when they come together, for example, every third 27.5 million years, the 8.9 million year will come into phase with it, if you take it as being 3 steps in that one. They got this data by using a 10 million year moving window. So this is the last 260 million years. I'll just mention again that these guys like to run their time axis the wrong way, from right to left. And they show the number of events that occur in that 10 million year period. We can see that quite clearly the activity is coming in bursts. It's nothing like regular. We get a big peak there, then a trough and peak, another big peak, and it's going up and down. And we can see that there's something that's going on that looks fairly regular happening over that whole time period. This one is a graph from Wikipedia. It shows, running from left to right this time, from 542 million years ago through to the present, and the different ages that have names from the Cambrian through. The whole thing is known as the Phanerozoic, and you can see that the first two intervals are similar size to each other, then the next one is about half that size, and then we have a number more of the same size as the first one, 1, 2, 3, 4, 5 of those. Then we have one that's about 1.5 times as long as the others. Then we return again to the same length. Now those ones that are all about the same length are all around about 53 million years long. The half-size one is about 27, and the 1.5 times long one is about 80 million years. And this was commented to me a long time ago, before this was as accurately known as this, by an amateur paleontologist who said all of those steps are multiples of 26.67 million years. They're 1, 2, or 3 steps. And I had to agree that he had that right. And the 26.65 million year is the thing that I believe is the most accurate estimate of that. This chart is one I produced quite a long time ago, in the mid-1990s. It was after I had made a visit to Russia and met Professor Afanasiev, a geologist from Moscow University. He's done a huge amount of work on cycles, and the most important thing is that he has found that the cycle, the longest cycle really known to geology, was called about 600 million years, or a little less, by Western geologists. He's determined that period to be 586.24 million years. And from that, I was able to work out one mystery that I hadn't managed to solve up till then, because I believe that those cycles were related all the way down to the ones at the human scale, which are further down here. In this table, I show different periods starting off in millions of years, then in years, and then all the way down. And you can see that they're related. For example, the first line, each one is half of the one before it, going down. And all those 5 periods are reported in different things, mostly the geology at this stage. And the next line you'll see that all of those figures have been divided by 11. I'll come back to why that is in a moment. But you'll see there 26.647 million years is an 11th of 293 million years, which is a half of the 586. And again, you'll come down to the next line where there's a 4.442. That's divided by 3. Whenever there's lines with nothing written beside them, they're a third of the previous line. And as we move across, they're half of the previous one. So there's lots of proportions of 2 and 3. This whole pattern of proportions of 2 and 3 had been observed by different people, but most notably was mentioned by Edward R. Dewey of the Foundation for the Study of Cycles. And if we move down to the lower right, we'll see a figure of 17.79 million years there. Dewey used 17.75, and he did times 2 divided by 2, times 3 divided by 3, and he produced a large number of those periods that I show there, slightly lower values than what I've got there. I think these are the best estimates. One of the things that's noticeable there is 11.86 year cycle. That is the period of Jupiter around the Sun. And when I used Afanasiev's 586 million year period and did the calculations with these exact ratios, it gave the period of Jupiter 6-digit accuracy at that point. And I had always regarded that period as the clock of the solar system. Jupiter is the most massive planet, and its period around the Sun, other things dance to the tune of that. And so the other periods in that range, those I think are the most accurate periods we can know for all of those cycles in the human range. Many of these things appear in many different things. The 4,600 and 2,300 year cycles appear in climate, and all these things appear in lots of different things as we go down there. So we can see that all of these cycles that people are finding in different things in geology, magnetism, and other things all fit one pattern. Climate cycles fit it. Climate and geology, of course, are intimately related, but other things, economic cycles fit it. Population cycles of animals fit it. All sorts of things fit the same pattern of cycles, which is derived from my own work, the Harmonics theory, and that says that the longest cycle is actually 10 million times longer than the age of the universe according to the Big Bang people. So I'm saying quite categorically, the Big Bang has got it horribly wrong. The Big Bang is bung. The longest cycle is 1.4 times 10 to the 23 years. And when I use that figure, I can calculate out all these common cycles from one simple fundamental principle, that the universe consists of a standing wave, and because the universal law is nonlinear, each wave generates harmonics of itself. And those waves become standing wave structures in the universe also, and each of those develops harmonics of itself. And this production of harmonics and harmonics of harmonics goes on all the way down until we reach the human scale. And the calculation of that from that one simple principle and the one starting period there gives it a very accurate fit to all the known cycles, almost all the known cycles in the range 600 million years down to about a month or a little less. There are a lot of cycles lower than that. It doesn't extend beyond that, and there are some possible reasons for that, which further work needs to be done on. So we'll see cycles are in everything. They're fascinating things. We can learn a lot more about every field if we include cycles studies. Edward Dewey said that if we study any field, medicine, geology, climate, and the affairs of men, economics, without the knowledge of cycles, then we're working in the dark the same way that medicine was before the discovery of germs. He said that in 1967. In the vast majority of fields, people still haven't learned this, and they're still assuming that whatever they're studying, the causes are immediately related to the thing, or at least closely related. They don't realise it's the whole pulse and the whole oscillation and fluctuation of the universe. When we understand that, we can then see that a lot of the things that are happening, including pandemics, for example, which we've just about finished having one of, or we're well into it, we hope, the timing of those is predictable. The year before this latest pandemic started, several astronomers had worked with Fred Hoyle, predicted the starting of that pandemic, that it was going to happen in the following year. There are solar cycles that can control these things. They control the cosmic rays coming to Earth. And there was a huge pandemic in London in 1665. One of the solar cycles is 355 years. If we add that to that, we get 2020, when we got this pandemic surging away. So cycles can help us to understand things and possibly be more prepared. So I hope you've enjoyed this talk. I've ranged over quite a few issues, but I wanted to try and put the stuff in perspective, that all the affairs of men and all of the things that are hitting on us and landing us and banging us about this way and that way are all actually potentially predictable. And so I hope that you find it interesting, and I look forward to seeing you next time, maybe.